Okay. So it is my distinct pleasure to introduce your next presentation. This is the big group. I think there's 8 of you. Is that right? Yes. So yeah, maybe some insight into the group working process there would be interesting. But this is predicting stars, a text analysis of Yelp reviews. So give it up.
So we'll just have everybody introduce themselves very quickly. Yeah, your name and then what institution you're from.
Okay. My name is Eugene Uiragie. I'm a PhD student at NT Greensboro. I'm working in medical images classification.
My name is Chao Liu. I'm a PhD student in sociology at NC State.
My name is Helen Liu. I'm an assistant professor in strategic communication at Seattle U.
Hi, my name is Lawrence Whitley. I'm a manager in the clinical research informatics group here at RTI.
My name is Ben Allaire. I'm an RTI employee. I'm a research economist in the public health economics program.
I'm Claire Gilliland. I'm a PhD student at UNC Chapel Hill in sociology.
I am Ria Kondu, a postdoc at the Department of City and Regional Planning at the University of North Carolina, Chapel Hill.
I'm Qinghua Yang, assistant professor at Texas Christian University, focusing on health communication and new media.
So first, we're going to thank RTI for hosting us. It's been a pleasure being here, and also everybody involved with the Summer Institute in Computational Social Sciences. It's been an amazing learning experience, and also we got the opportunity to work in a topic of our interest, which is predicting stars, a text analysis of Yelp reviews. The motivation of this work is that Yelp Online Reviews provides an abundance of information regarding reviewing restaurants. So users can go online and find out where they're going to dine next. They also have the opportunity to be themselves the reviewers and provide a score to its establishment from 1 to 0, 1 the lowest, and from 1 to 5, 1 the lowest and 5 the highest, and provide also a text that kind of justifies their scoring. Here we are trying to predict the number of stars that are associated with its restaurant review. And we're taking into account text that is provided by the reviewers, as well as certain characteristics of the people that provide these reviews. We leverage data from the Yelp Dataset Challenge in order to accomplish that, and we're not the first ones to do so. Doing a Google Scholar search, we see that a lot of people are interested in addressing that, and Yelp has actually a challenge to motivate people to study such topics. This is a big data set. The Yelp Dataset Challenge has more information for more than 200,000 local businesses in 10 different metropolitan areas in the USA and Canada, corresponds to 6.7 million reviews from 1.6 million users. In order to conduct the analysis in such a short amount of time, we randomly selected 1,000 establishments, restaurants located in the United States. And with those establishments, approximately 83,000 reviews were associated with. So in order to perform the analysis, we had to match the reviews file with business information as well as with user level data. More than 63,000 reviewers provided feedback. A little bit more about the descriptive statistics of our data set. 137 cities those reviews corresponded to. The top 5 locations were Las Vegas, Phoenix, Charlotte, Scottsdale, and Pittsburgh. Again, only 21.5% of the reviewers were attributed the elite status. which corresponds to the fact that they are doing reviews frequently and they provide high quality reviews. When it comes to our dependent variable, which is the reviewing stars, we see a mean of 3.7 stars and a median of 4, so a left skewed distribution there. And looking into the network of the reviews, the businesses and the users, we decided to do an initial analysis and map pairs. So on your left-hand side, you can see the reviewers business network, and on your right-hand side, the reviewers review network. What you see on your left hand is essentially in the periphery reviewers that only conducted a review of one business. And then in the center of in this hairball, essentially you can identify restaurants as clusters by reviewers that are connected because they have provided a review for that business. On your right-hand side, you can see the review network, identifying reviewers that have only provided a review for one establishment in the periphery, and in the center, reviewers that have provided more than one review. And I will leave it up to Claire, who is going to provide more information on the text analysis that was conducted.
So one advantage of being a larger group is that we were able to have a couple moving parts all going at the same time. So I'll share about the text analysis, which we use sentiment analysis, and then we'll present some topic models, and then we'll show how we combined both of those into our machine learning model in order to predict our eventual outcome of the number of stars. So for our initial data processing, we used the tidy text packages we learned last week. We dropped the stop words or the common words that don't add much meaning and the non-text characters. We did not stem words in this case. And just to show you a little bit about what words are included in our corpus of text, we see on the left-hand side the frequency. So food, unsurprisingly, is the most common word in our data set, but also includes things like service, time, menu, friendly. All of these things we would expect would come up in a restaurant review. And on the right is just a broader network of some of the words that came up. In our sentiment analysis, we experimented with two different dictionaries. So one of them is the AFIN dictionary, which rates each word on a score of -5, meaning a negative word, to +5, meaning a very positive word. And then within that, you would take the score of each individual word, group it by the review ID, so the actual text review, and get a compound summary score of whether the text is very positive, somewhat positive, neutral, all the way down to very negative. But we also worked with the Bing dictionary as well, which is a little bit simpler. It's simply positive words or negative words. And on the right, you can see just an example of some words and how they would be coded in the two different dictionaries. And so we see outstanding would be very positive versus friendly as just the score of 2. But also you'll notice that delicious is included in the Bing dictionary, but isn't in the AFIN, which is relevant to restaurant reviews, as well as pushy would be included in the AFIN and not in the Bing. So that's why we decided to just work with both. Some descriptive results, we do see that this sentiment composite score in the box plot on the left is, at least descriptively, seems to have a positive correlation, so that a better sentiment score or more positive score is associated with getting more reviews. Another way we descriptively looked at our text was to look at bigrams or pairs of words. And what that can help us to do is identify compound words as well as negators and amplifiers, which I'll show on the next slide. And so we didn't end up adding these into our dictionary, but it is useful to think about words that would come together. So for example, happy hour is common in our data set and might get miscoded because it would see happy and code that as positive when really it's referring to this activity or this compound word. Similarly, we're missing negation and amplifiers in the way that we are doing sentiment analysis because we're only looking at one word at a time. So the left, you see words preceded by not. So in this case, it would be not good, not bad as well. And so that flips the meaning of this, as well as amplifiers or things that are really playing up how much they loved it. So very nice, really friendly, really impressed, all of this. So we're not accounting for this in our unigram approach, but it was something we thought about descriptively just to get a better sense of the text in our data set.
And I also ran structural topic modeling, and as a couple of previous groups mentioned that a key advantages of structured topic modeling compared to the previous mallet approach is that it could incorporate arbitrary metadata and can then allow a researcher to investigate the relationship between topics and other covariates. So we first take a look at the optimal topic solution using search key function, which is a data-driven approach, and which takes forever. So it's like if you have a large data set and if you run a wide range of topic solutions, you may want to take a nap and come back while the computer's running. So when you can take a look at how the likelihood, you can see that the second derivative kind of reaching the maximum around like topic 4 and topic 8. And for the residual and semantic coherence and lower bound, kind of telling the similar story. And so we try to we try the 8 topic solution and 4 topic solution. And we would like to run more topics if we give a longer time. And after we nail down the topic solution and we generate the loading of topics as a predictor of number of stars using the theta posterior function. So this is the 8 topic solution. You can find that there's a couple of topics such as topic 2, like breakfast, topic 4, chicken, and topic 5, steak salad, are kind of correlated. And also topic 6, just about like the waiting time to be seated and to be served, and topic 7, which is like, order time, are kind of correlated, which is unsurprising. So we figure out that probably we can reduce the granularity and also for avoid overfitting the model that we are going to predict the number of stars. So we examine the 4 topic solution. So you can take a look at the top words based on the highest probability for each topics to get a general idea about what each topic talks about. And you can also based on other statistics such as Frex, Lift, the details of which can be found in the Margaret Roberts VNet. So here you can take a closer look at like the top words, for example, for food types, which emerge like the chicken, salad, and also for great impression, which very broad and general. And for service, you can see the word service pop up. And also what time is money. It's like the order and the times emerged. Lastly, we also take a look at like the correlation, bivariate correlation between the topics as well as the number of stars. So for those who mentioned food type, general impression, and service, kind of given lower stars, versus like those who mentioned about time is money, kind of giving higher stars.
Thank you, Candy. So all of this was building to wondering what info can be useful as star predictors. So we built those review level predictors on the sentiment analysis, so that's the AFIN score and the number of positive and negative reviews. And then we also had topic loading. So that's from the review level. Then we brought in some user level predictors. So that's the number of reviews a user has, average ratings, years of being an elite user, total number of useful votes. So that's reviews of reviews, and then total number of fans that the reviewer has. And so this was so as we were hoping to provide to put together supervised machine learning techniques. And so we started out with just a simple OLS regression, looking at what these in terms of what these variables provided in terms of prediction of scores. And we had an R squared of 0.468, and we also saw that several of these variables were highly significant predictors of what the Yelp stars were. Then our first foray into predicting stars was our first machine learning model. And so we trained this model to predict the ratings based on the full text of the reviews. So all the words that were coming out of the reviews. And our training set was about 80% of the reviews with 1 and 5 stars, and then we dichotomize those into 4 and 5 stars as positive reviews and 1 to 3 stars as negative reviews. And we used a variety of different algorithms, a logistic regression, a random forest, and a multinomial naive Bayesian or MNP model. And then we used an XGBoost to reduce the text, to distill it down into its most important features, and then we tested on 20% of the reviews. And so our best result for that one was a 94% accuracy, and that's just predicting with the dichotomized reviews. So from there, we expanded our model set and sought to predict all 5 categories of stars. And so we used a neural network. And we used the sentiment analysis and the topic modeling as inputs into our neural network. And neural networks, as an explanation of that methodology, it's so they generally tend to model complex relationships between a set of inputs and a set of outputs by mimicking biological neurons. So this was our neural network, and it's kind of a complicated gobbledygook on there, but you can kind of see that we had 2 hidden nodes. We trained this model. We found neural networks are very computationally intensive, and getting the model to converge was a major challenge for us. And so we actually only trained it on a very small set of observations. If we expanded those set of observations, we actually found that the model fit was actually not all that much better. And this model that we concentrate on, it's a feed-forward model, and we ran a zillion different models with both simple and complex. The model that you're looking at had the highest level of predictability in order to predict the stars. And so it had 2 hidden nodes, but we tried 1 to 5, and then our final model had 2 with an activation function of a sigmoid or a logistic activation function. Here is our kind of hit matrix and how well we predicted. You can see, I thought this was interesting. We were able to predict 1 stars really well and 4 stars really well. And we do okay on 5 stars, and we miss on 2 and 3 star reviews. And I think those are, that's really the challenge. And we ended up picking our model based upon the correlation between the actual and the predicted values in the test set, and that was 0.772 roughly between those. A note on model overfitting. We also have our model predicted some 0 stars and some 6 stars, but in general we did very well on the very negative reviews, and we did okay on the pretty positive reviews. As I noted, model overfitting is a challenge. The other challenge that we came across was that the network model can be unstable. So finding the network model, the correct one, can take time. So there was definitely noise with that. And the sentiment score, you can see back here, it was a very strong predictor. You can see that one all the way at the top there. And the full model was better with all the variables than any dropped column. So we checked that out too. So what we would have done differently in terms of text analysis, handling negation and amplifiers, we would have done that a little bit differently, incorporated that. We would have done some sensitivity analysis around testing different dictionaries. And then some reviews had no sentiment at all, and we weren't sure what to do with them, so we set them at a default of 0. But I think if we had more time, we'd probably look into that a little bit more. And then for unsupervised machine learning, that was the topic modeling. We would do a closer examination of the text for each topic, and then multiple iterations of generating topic loading. And then for our supervised machine learning, in order to predict the stars, choosing the appropriate model took us a very long time, and that was definitely a challenge. And as well with the stability of the model, setting the seed actually made a very large difference in our ability to predict the outcomes. And then finally, we did have some very interesting discussion over the interpretability versus prediction accuracy. What what does the scores mean from the neural network? It's kind of a black box approach, and you're just trying to maximize prediction, whereas we were trying to figure out, what do the coefficients mean, or what do the weights mean? So thank you very much. That is the end of our presentation. Appreciate you listening.
Okay, any questions?
So just a quick question. What package did you use for the neural networks?
Neural net.
Neural net
in
in
R.
R.
Yeah.
That was it.
Reference there.
Yes.
So
Is it?
the fifth.
The fifth restaurant. Oh, yeah, there it is. Yep.
Are you guys?
So given that we had so much trouble just loading the main data set with all of the reviews, because it is an enormous data set, we probably won't be gunning for the $5,000 to predict the stars. But definitely we could think about it, because I think our model actually did, for 3 days of work, I think having a correlation between the predicted and the and the actuals of 0.71 is pretty good. It's not bad.
Also, only students can win the $5,000, so Chow and I might take it and run with it.
Okay, so I'm just wondering, do you have any weighting for the different ratings, the text for different ratings? Because you see that you have a very skewed distribution, right? You have a lot of reviews for 5 stars, but you don't have much for 1 to 2 to 3. So I'm just wondering if you have done any kind of weighting in terms of the text.
In terms of the text.
In the neural
net. We're fairly confident that if you took the sentiment based on 2 and 3 word phrases that go together, like happy hour, but not bad, not good, if we took those into account, we think that those ratings would fill in the gaps a lot, because there's so many words that are going to alter the meaning of a single word in terms of sentiment. So that's where we think that this could be changed a lot with more time, of course.